When you take your car to the mechanic, he lifts it way up high so he can get underneath it. How does he lift such a massive object like your car up high? Well, he uses a hydraulic press. And a hydraulic press works like this. You have some input force, which is labeled F1, and this is the force applied to the hydraulic press. And then you have an output force labeled F2, and this is the force that comes out on the other side, the force that lifts your car. On the input side, the surface area of the piston is labeled A1, and it's this guy right here. Come on, smartboard, you can do it. There we go. And on the output side, we have another piston labeled A2, which is this guy right here. And what's important to note is that in between the two pistons is a liquid, and liquids are non-compressible. Therefore, whatever pressure you apply on one side, you will get the same pressure out on the other side. By definition, pressure is force divided by surface area. Excellent. And now if we multiply both sides by A2, we can isolate for F2 the output force. And we get that F2 is equal to F1 multiplied by the ratio of the areas A2 over A1. You can see in the picture that the surface area of piston 2 is larger than the input surface area of piston 1, and therefore F2, that is the output force, will be much larger than the input force. And in fact, if we look at the picture, we can say that this guy is about 5 times larger radius than this guy right here. And so we'll say that the radius of this guy is equal to 1, whereas the radius of that guy is equal to 5. And now we can compute the ratio of the areas. So A2 over A1. Well, what is the area? It's just the area of a circle. So that's pi r2 squared over pi first piston radius squared. And we see that the pi's cancel right off the bat. And if we plug in those numbers, we said that the second piston was 5 times larger. So we get a 5 squared over a 1 squared. Well, that's just equal to 25. So under these circumstances, for the numbers I just gave, we would get that the output force, F2, is equal to 25 times the input force, F1. So you multiply your force by 25. Not a bad deal. Now, are we getting a free lunch here? Nope, we are not. Because recall that this side is much skinnier, so in order to lift this guy, this little bit here, this guy will have to be pushed down much, much farther. And you can see that because the volume of water displaced by this much of a push will only equal this much of a push up on this side. In other words, what are we talking about? We're talking about conservation of energy. So the work that you put in on side 1 has to equal the work on side 2. Therefore, the force times the distance the piston is pushed on the input side has to equal the force times the distance that it rises on the output side. So if this guy is 25 times smaller than this guy, then the distances have to make up for it. This guy has to be pushed 25 times farther than you get out on the other side. Cool. So this is how a hydraulic press works.